So it was 27th May.
So you submitted today, that means, right?
I didn't submit. It was expired.
But that means you did it today.
Yes.
Oh, okay. So I think 27th May was a reasonable date, right, Zed?
Yes, sir.
So after this, try submitting like before the next, at least one day prior to the next class. Okay.
Yes.
That way, I can see your assignment also, na? Then we can discuss if you have did something wrong, or if there is a better way of doing something else, right?
Yes.
Take care of that. And what was the topic? You said non-ideal and ideal, na?
Yes, sir.
Okay. Now, I want to start today's class with a concept which is known as distillation. You must have heard about distillation.
Yes, sir.
Right, distillation. Do you remember what is distillation? Don't write this, okay? Don't write this. What is distillation? Do you remember?
It is purification of water.
It has to do something with purification, right?
Yeah.
Correct. Okay. Do you remember something about the process?
It is the process is known as.
No. What I don't want to know what is it called. I want to know what happens in distillation.
This distillation is related to osmosis in our chapter. So should I talk about that?
No. Distillation is not related to. You tell me. Don't solution which पढ़ दीजिए ना. उससे पहले भी distillation पढ़ा है ना आपने. वो बताइए आप.
So when there is a.
What do we do? Do you remember some of the apparatus?
Yeah. We take a distillation flask.
कोई container में पानी ले ले. Container.
Then we use filter paper and we distill the sediment from the water.
That is filtration. No?
Filtration.
That is filtration. Distillation.
SPM means like a semi-permeable membrane. We.
No. You don't. No. Distillation. Semi-permeable membrane के बारे में हम क्यों बात करेंगे? We are not talking about anything else. When did you hear about distillation? Tell me. Somewhere in 9th standard, 10th standard, right? है ना? इस chapter में तो पढ़ा ही नहीं होगा आपने, है ना? है ना? So it is not related to this chapter at all. Okay. So इसको किसी concept से जोड़ने के भी आप कोशिश मत कीजिए. वो मेरा काम है. Okay. So distillation, if you remember something.
Boiling of water.
कुछ याद आ रहा है आपको?
Yes.
So we turn the water into vapors.
Then again liquid.
We cool them, है ना? Inlet of water, outlet. Here we have cold water, है ना, which passes through it, liquefies the vapors, right? Liquefies the vapors. Now, the principle of distillation is that if I have liquid A and liquid B that are present in the solution, right? We have a solution of liquid A and liquid B. Now, liquid A, it boils at, let us say, 100 degrees Celsius, and liquid B, it boils at 200 degrees Celsius. Okay? Right? Now, what do we have in the solution? We have both A and B. Now, when I start to heat this thing, what will happen? The temperature will start to rise. The temperature will start to rise, and it will start 30, 40, 50, 60, 70, 80, 90, 100, and 100. At 100, what will boil?
Component A.
Component A will start to boil, right?
Yes.
And when it starts to boil, I hope you remember that the temperature won't change while it is boiling because of latent heat of vaporization. Whatever extra heat we are giving, it will be used in order to convert the A to its vapor, right? The liquid A to its vapor, and not to increase the temperature. So what will happen till the time A is boiling, what is going to happen now? What is going to happen? The temperature will be constant, right? Temperature will be constant. Okay. Alina here. Alina is here. Assalamualaikum, Alina. How are you?
Hi, sir. I'm fine.
Fine. Okay. So what did we learn in the last class? Do you remember, Alina?
Yes, sir. We learned about mole fraction of each component in vapor phase.
Mole fraction of each component in vapor phase. Okay.
Yes.
And after that?
That was the last topic I have written in my notebook.
Acha. So when was the last class you did?
Sorry, sir.
When was the last class that you did? Last Sunday?
On Sunday, I guess.
Sunday you did. I think then you must have learned about ideal, non-ideal also, right? Positive deviation, negative deviation.
No, sir. No, sir. It was on Saturday. Yeah.
Your last class you did on Saturday.
Yeah.
Sunday आप नहीं आई.
Like.
Did you get the recording? Adi, did you ask for recording?
No, sir. Like I did not know. Okay, Sunday we had for chemistry. मुझे physics की link तो मिली थी, but like I only knew about this.
अच्छा, you did not get any link for chemistry on Sunday?
Yeah, sir.
Okay. Just wait a second. Okay, thank you for telling me that. Okay, so so today we are starting with a bit of distillation. Okay, distillation, we are understanding the concept, even though it is not present, but it is related to one of the topics. It is related to one of the topics, and sometimes they can ask you questions related to that topic on distillation. So in distillation, I hope you remember, Alina, we purify substances, right?
Yeah, yes, sir.
Hana? And it also in that distillation we also boil things in order to purify, right? We boil things, and what happens when we are boiling, for example, if I have two components A and B, and A has having temperature which is 100 degrees Celsius, that is the boiling point of A, and 200 degrees Celsius is the boiling point of B. Now when we start to heat, obviously A will start to boil first, and the temperature will start to increase from 30, 40, 50, 60, 70, 80, 90, 100, and at 100 it will be still 100, even though if we give more heat, that will be utilized in order to convert the liquid into vapor, and convert the liquid A into its vapor, right? Now that is why the temperature will not increase. So you will see a constant 100 degrees Celsius for a long time. For example, 3 to 4 minutes, you will see that 100 degrees Celsius is maintained. Now at this point, 3 to 4 minutes, what is happening? A is boiling off. Now when A will boil off, what will happen? It will form vapors and it will go above, right? It will go above and it will follow this path of the pipe. Now here we have cool water. Here we have cool water. And as soon as these vapors, they enter this part of the pipe, what happens? They will get cooled and they will liquefy. And at the end, they will be droplets and we will just collect them in a funnel. We will just collect them in a funnel. Okay. So this is how distillation is done. That means as soon as 100 degrees Celsius is reached, and then you see that 100 degrees Celsius the temperature starts to increase. Now the temperature will only start to increase. It will only start to increase when A is completely boiled off. Okay, when A is completely boiled off. Is that clear? Yes or no? Zaid and Alina?
Yes, sir.
Yes.
Okay, fine. Now, so, but what if let us say we have two different components. Let us say acetone and chloroform. Now, acetone is C double bond O, hydrogen, hydrogen, and chloroform is hydrogen, C with chlorine, with 3 chlorines. Okay. Now, individually, if I see acetone will be polar, chloroform will also be polar. Now, both of these things are what? Both of these things are polar. But when I add them, what will happen? As you can see, this hydrogen, it will be highly delta positive because it is connected to carbon, which is further connected to 3 chlorines. So hydrogens, all of the electrons will be pulled off, right? And this oxygen, it has lone pair and it also is delta negative because of high electron activity. Now, as soon as we mix these two things, there will be a hydrogen bond formed between the oxygen of acetone and chloroform of and hydrogen of chloroform. Okay, so it'll form a hydrogen bonding. Now, this hydrogen bonding is present in the mixture, but hydrogen bonding is neither present in the components. Like it is neither present in acetone nor it is present in chloroform. Then obviously, if it is having hydrogen bonding, if the mixture is having hydrogen bonding, then its intermolecular force of attraction is higher than both of these components, acetone and chloroform, and due to high intermolecular force of attraction, its boiling point will be higher, right? Its boiling point will be higher because the molecules, they will be attracted towards each other with a higher magnitude. And if they are attracted towards each other with a higher magnitude, they will not escape out easily. And that is why the boiling point will be higher. The boiling point will be higher. Is this clear that their boiling point will be higher? Yes or no?
Yes.
Yes.
What about you, Alina? Okay. Now see here, if the boiling point is higher, that means what? Distillation we cannot do any distillation. Why? Because this mixture will have its unique boiling point. It will neither depend on the boiling point of acetone, nor it will depend on the boiling point of chloroform. This mixture will have one boiling point, which will be higher than that of acetone and that of chloroform. And that is why this cannot be distilled, right? This type of solution, it cannot be distilled. Okay, this type of solution, it cannot be distilled. Now, the solutions which boil at constant temperature, right? For example, the mixture of acetone and chloroform, they will boil at a constant temperature which will be higher than that of acetone and chloroform. These are known as azeotropes. Okay, so write the topic, azeotrope. What is azeotrope? Azeotrope is a mixture that boils at a constant temperature. That boils at a constant temperature. Now, azeotropes are of two types. Azeotropes are of two types. They can have a temperature which is higher than any of the components, or it can be lower than any of the components. Okay, so there are two types of azeotrope. The one which have higher boiling point than both components. Okay, higher boiling point than both components. These are known as maximum boiling azeotrope. Okay, these will be known as maximum boiling azeotrope. And there are some which have lower boiling point than both components. Lower boiling point than both components. Okay, and these are known as minimum boiling azeotrope. These are known as minimum boiling azeotrope. Okay. Next point, this higher boiling azeotropes. These are when these will have higher boiling point, that means they will be forming less vapors, right? They will be not forming vapors easily. If they are not forming vapors easily, that means their pressure will be low. The pressure total will be low, and that is why these are shown by solution with negative deviation from Raoult's law. Okay, and minimum boiling azeotrope, these are shown by solutions with positive deviation from Raoult's law. Let me know if you have done writing this down. Okay, Alina is done. Waiting for Zan. Thank you, Zan. Okay, moving on. So till here we have learned about different type of solutions and their different properties. Okay, and now we are going to learn one of the last topic, that is colligative property. Colligative property. Okay, colligative property. So what are colligative property? Colligative properties are those properties which do not depend on the nature of solute. Which do not depend on the nature of solute. Which do not depend on the nature of solute. Rather, it depends on the amount of solute. It depends on the amount of solute. For example, please don't write these things. Okay, please don't write this. For example, you have learned Henry's law. Now, Henry's law, it suggests that the pressure is equal to KH into chi b. KH into chi b. Okay. Now, this chi b is what? This chi b is telling me amount. And this KH is telling me the nature. Right? This KH is telling me the nature. Similarly, we have learned about Raoult's law. Raoult's law says that P is equal to what? P naught into P naught of A. P of A is equal to P naught of A into chi A. Now this tells me amount of solute that we have dissolved, and this tells me what is the solute that we have dissolved. That is the nature, hai na? Whether we have dissolved a solute which is water or ethanol or something else. Now all of these two laws, the Raoult's law and the Henry's law, as you can see, they also depend on the nature of solute and also on the amount, right? They depend on the amount as well as the nature. But colligative properties are those properties which will depend only on the amount of solute that you have added. It will not depend on the nature of solute. That means they don't want to know, or they don't depend on what is the solute. They just depend on how much is the solute. They just depend on how much is the solute. Okay, so please write with me the definition, the properties of solution which depend only on the number of solute particles. They are also known as, aka democratic properties. No, because it just depends on the number. It doesn't depend on the nature, right? Democratic properties. So this definition is also very important. It has been asked like many times in CBSE examination. The dates which I can remember is it has been asked in 2015. What is colligative property as it is, and also I think in 2017. So they can ask you directly what is colligative property. So this definition is also very important. Okay, the properties of a solution which depend only on the number of solute particles. Okay, only on this word only is very important. Only on the nature of number of solute particles. Now, there are 4 colligative properties. There are 4 colligative properties. Number 1 is relative lowering of vapor pressure. Second is elevation in boiling point. The third is depression in freezing point. Fourth point is osmotic pressure. Fourth is osmotic pressure. Relative lowering of vapor pressure, in bracket you can also write RLVP. Okay, So these are the 4 colligative properties that you will start, and starting with relative lowering of vapor pressure, and after that elevation boiling point, depression freezing point, and osmotic pressure. Let me know if I can move on. Okay, now you will not write, okay? You will not write, just listen. If I talk about solutions which can have the liquid as the solvent as liquid, है ना? So we can make a solution of liquid plus gas. We can make a solution of liquid plus liquid, and we can make a solution of liquid plus solid. So if liquid plus gas is there, then which law is applied? Tell me. Which law is applied?
Henry's law.
Henry's law, right? And also you must know that if I have liquid, right? I have liquid and I have gases here also, right? There are gases. Now, if I talk in terms of the ease of escape, right? So which will escape easily? Which will escape easily, liquid or gas from the solution? Yes, Alina, which will escape easily?
Sir, gas.
Gas will escape easily, right? And that is why you see that the pressure, now the gas will escape here and it will apply some pressure. So this pressure is only dependent on KH into chi B. It is only dependent on the solute. It does not depend on the solvent. But if I look at liquid plus liquid, let us say A and B are liquid here, right? And if I mix them, I will get A and B. Now you tell me which has the tendency to escape, A or B? Both will have tendency to escape, right? Yes or no? Because both are liquid, right? And that is why Rawls law says that P total is equal to P naught A chi A plus P naught B chi B. Okay. But if I have liquid and solid, now if we have liquid and solid, then in this case, you tell me which will escape, liquid or solid, or both?
Liquid.
Only liquid can escape, right? The solid, it cannot escape the solution. And that is why, this is relative lowering of vapor pressure. Okay. So please remember, liquid plus gas, always Henry's law. Liquid plus liquids, Rawls law. And if it has liquid plus solid, then it is RLV, relative lowering of vapor pressure. Relative lowering of vapor pressure. Now you will understand. The formula also, what is relative lowering of vapor pressure. But here I will give you a small idea. See here, what the pressure, it will be only dependent on. Pressure will be only dependent on the mole fraction of A. That means the solvent. And that is why you'll say the pressure is only dependent on P naught of A times chi E, right? Times chi E. We can also write like this. We can also write P naught of B into chi B. Here we are taking B as the solute, which is solid. B as the solute, which is solid. But P naught B will be equal to what? 0. In the pure state, if I look at salt is not going to give me any vapors now. So even if we apply the Rawls law in this case, it is going to give me the same answer. It's going to give me the same answer, that the pressure will be equal to only P naught A chi A, because P naught B will be equal to 0. Is that clear? Yes or not? Tell me. You got this point? Okay. Now, let us write relative lowering of vapor pressure. Relative lowering of vapor pressure. Now, relative lowering of vapor pressure. Now, first of all, relative lowering of vapor pressure will only be seen in those solutions which have solid solute. So please write, when a non-volatile solute. So non-volatile is a more CBSE way of writing solid. Okay, non-volatile means something which at room temperature does not give any vapor, that is non-volatile. So when a non-volatile solute is added, or you can also write dissolved in a solvent, is dissolved in a solvent, the vapor pressure of solution decreases. Solution decreases and it becomes lower than that of pure solvent. Now this is known as RLVP, relative lowering of vapor pressure. Okay, so I can explain this also. Okay, can you please pause for a minute? No, just pause for a while. We will explain this. Okay, let us suppose here we have a situation in which we have pure solvent. Pure solvent, that is A. And here we have a solution. Solution we have A plus B. Okay, A plus B. So A is your red one. Okay, A is your red one, and B is the blue one. Okay. Now, as you all know, B is what? B is solid. B is solid. So obviously, if I look at pure solvent A, that means in the surface we have a large number of A molecule which can easily escape and it can form vapor. Yes or no? If we have only liquid?
Yes.
But as soon as we add solid, what is going to happen, Anina? It will acquire some space in the surface. Yes or no? Can you see that? Right. So when it will acquire some space in the surface, what is going to happen? It will not let A to escape as easily as possible, right? It will hinder the vaporization of A. And if A is not getting converted into vapors, then what will happen? The vapor pressure will be lowered. Is that clear? Yes or no? Please tell me.
Yes, sir.
Yes.
Okay. Please write this down. Okay, Alina is done.
Sir.
Done. Okay. Now. Right. Since the vapor pressure of solution with non-volatile solute depends only on the solvent. What we can say that pressure, it will be equal to, now pressure, it will be equal to what? It will be equal to P naught of A into chi A. Is that clear? Yes or no? Please tell me.
Yes.
Sure.
Okay. Now this will be what? This will be P total only. This will be P total. Now we can also write P total will be equal to P naught A into 1 minus chi B, because chi A plus chi B is equal to 1. That will imply chi A be equal to 1 minus chi B. Is that right? Yes or no? Please tell me.
Yes.
Now moving on, we can write P naught of A minus P naught of A into chi B. This is equal to P total. This is equal to P total. Now what I will do, I will place this P total here and I will give this P naught A here. Okay, so it will become like this: P naught of A minus P total is equal to P naught of A chi B. Okay? Agreed, right? No problem?
Yes.
No, sir.
Alina is there, no problem, right? Okay. Okay, now what I will do? Now this expression here, it is known as lowering of only, lowering, not relative, only lowering of vapor pressure. Okay, this is known as lowering of vapor pressure. But when I related this with P naught A, when I relate the lowering with P naught A, that means I am writing P naught A minus P total upon P naught A. This will be equal to chi B. Now this is known as RLVP. Okay, this will be RLVP, relative lowering of vapor pressure. Please write this down. Done. Okay. Right now, write a point here, determination of molar mass of solute using RLVP. Okay, but also remember this is only for dilute solutions. That means we are going to add a very little amount of solute. Now, let me give you a situation and then I will explain it. That will make it more easier for you guys to understand and appreciate the method. Okay. Let us suppose we have here we have put water, H2O. Okay, and then we added some solute, that is B. Is that clear? Yes or no? Please tell me.
Yes.
What we have done? Okay. Now what we want to know? We want to know the molar mass. Okay, we want to know the molar mass. Now, please listen here very carefully. Please listen very carefully. What do we have? We have this determination of molar mass using RLVP. RLVP means P naught of A minus P total divided by P naught of A, which is equal to chi B. Please don't write this. Listen here, chi B, right? All of you agree? Now, can I know P naught of A? That means what is the vapor pressure of pure water? I can know that, right? Yes or no?
Yes.
Looking at the data booklet. Yes, Arina, agreed? We can know and we can check for P naught A from data booklet. Yes or no? Experimental point of view se bata rahe. Or else what you can do? You can just take water, cover it, put up a manometer or a barometer and check the pressure. This will be the pressure for pure A. Yes or no? Alina and Zan?
Yes, sir.
Yes.
Okay. Now we can also do the same thing. We can cover this, and we can put up a manometer or a barometer, and then we can measure the pressure here, and it will give me the P total of the solution. So we can get this. Okay. Now, what is chi B? Chi B, it is equal to number of moles of B upon number of moles of A plus number of moles of B. Now, since we have taken a dilute solution, what we have taken? We have taken a dilute solution. That means we have added a very little amount of B. That means the amount of B will be very, very less if I compare that to A. And that is why what we can write here, P naught of A will be P naught of A minus P total upon P naught of A will be equal to the number of moles of B upon the number of moles of A. Yes or no? Please tell me.
Yes.
Yes, sir.
Right? Because we have a dilute solution. No. As we will write as NB is very, very, very small than NA. B is very, very small than NA. Now, all of you know what is NB? NB is what? The given mass of B divided by the molar mass of B divided by the given mass of A divided by the molar mass of A. Yes or no?
Yes.
Yes, sir.
Okay. Now this will be equal to, I will write WB upon MB into MA upon WA. This is equal to what? P naught A minus P total upon P naught of A. Now, in this case, as you can see, we can measure this, we can measure this. Now, W of B, the amount of solute that we have taken, we can measure it and we can add it. Right? The mass of solute that we have added, we can measure it. Right? The solvent, so water, if you have taken as solvent, then you know the molar mass of solvent and the amount of solvent that you have taken. The only thing that we don't know here is molar mass of B, and then you have linear equation in one variable, linear equation in one variable, and you can easily solve this. And if you want to write this in terms of MB, then you can also write MB. The molar mass of solute will be equal to WB into MA upon MB into this P naught A will go above upon P naught A minus P total. Please write this down. Okay, if you have written, please write each and every point. What is P naught of A? Vapor pressure of pure solvent. Solvent. Solvent, right? Solvent.
Yeah.
What is P total? Vapor pressure of solution. Now, what is W of B? It is the given mass of solute, right? That is amount of solute added. Solute added. Now, secondly, what is W of A? Is the given mass of solvent. We can write amount of solvent added. Nextly, what is M of A? Molar mass of solvent. What is MB? Molar mass of solute. Alina, can I
Yes.
just got to know that you got the link on Sunday for chemistry at 4 p.m.
Sir, then I don't know, actually it's on my dad's number. So
अच्छा, so like you take care of my classes, okay?
yeah.
देखिए एक तो लिंक सेम रहेगा आपका, ठीक है? It will be KSA
Okay.
4 p.m. Saturday and Sunday, okay?
Yeah, okay, sir.
Okay, so please remember same link, okay? The link is, I think it starts 999 करके start होता है, okay?
Yeah.
ठीक है, चलो. Done? Alina, done?
Yes, sir.
Okay. So let us do one question, okay? Write the question. Solution is prepared by dissolving 10 grams of non-volatile, 10 grams of non-volatile solute in 200 grams of water. The solution has a vapor pressure of the solution has a vapor pressure of 31.84 mm of Hg and 500, let us say at 308 Kelvin. Calculate the molar mass of the solute if vapor pressure of pure water is 32 mmHg. Okay, this question has also been asked in CBSE examination, and these will be asked in 3 marks. Okay, please write the question. It's a very direct formula based question. Okay, since you have done, see, it's a very simple question. Okay, very simple question, in which what are the things that you have been given? What are the things that you have been given? You have been given 10 grams of solute. You have been given WB. Then what else you have been? Non-volatile solute in 200 gram of water. 200 grams of water means WA is equal to 200 grams. And the molar mass of A, that means molar mass of water, it is equal to how much? 18 grams per mole. Right?
Yes.
Next thing that you have been given, the solution has a vapor pressure of 31.84. You have been given P total, which is equal to 31.84. Then you have been given calculate the molar mass of the solute if vapor pressure of water is 32 mm. That means you have been given P naught of A, which is equal to 32. This is both mmHg. This is also mmHg. You just need to calculate for number of moles of molar mass for B. Easy, right? So MB will be equal to, you can just plug in the formula. What is the formula? Tell me. You have just written the formula now. Tell me what is the formula.
So P naught A minus PS means P total, that is solution.
MB is equal to, I have just written in the,
Sir,
you must have written, right?
WP into
WP
into
MA
MB into P naught A.
अच्छा MB लिख दिया हमने यहाँ पे, एक सेकंड, सॉरी, this will be WA, sorry, my bad here. WB MA यहाँ पे WA होगा. Okay, my bad. Here will be WA. Okay, into
P naught A.
P naught A
minus P total.
By P naught A minus P total.
ज्यादा आपने लिखा नहीं है क्या?
Yes, yes.
नहीं लिखा आपने?
I wrote.
लिखा है आपने? कैसे फिर आप गलत बोल रहे हैं? Send a photo now, ना, to Learnivio what you have written. गलत लिखा होगा तो फिर गलती हो जाएगी ना आपसे. Yes, Alina, tell me.
P naught A by
P naught A by
A minus
P total. Very good. So you have all the things, and you can plug in the values and please calculate. This will be 10 into molar mass of A will be 18 divided by W of A is 200 into P naught of A is 32 divided by P naught of A minus P total 31.84. 32 minus 30.84. 10 into 18 upon 200 into 32 upon 32 point minus this will be equal to how much? 0.64. Sorry, 0.16. 10 into 18 into 32 divided by 16 into 0.16 into 100, that will give you 16 multiplied by and multiplied by 2, it will give you 32. Okay, if you multiply this and this, it will give you 32. 32 and 32 will get cancelled, and you will get this as 180 grams per mole. So this will be the molar mass of the solute. Any guess what this solute can be? Any guesses here?
So it
No.
can be sucrose.
No, glucose. It will be glucose. Glucose. It can be glucose, not it will be, sorry. It can be glucose. Okay. Now, Alina, done?
Yes, sir.
So as you can see, how many lines are there? Just 3 lines, right? There are just 3 lines, and then you are scoring 3 marks for that. Okay. So please remember these small formulas. Okay, please remember the small formulas. Even if you don't remember it in this way, try to remember it in this way. Okay, that will be easier. This is what RLVP. RLVP is P naught minus P total upon P naught A, which is equal to given mass upon molar mass into molar mass upon given mass of the solvent. Okay. Now moving on, we have another. Okay, we have graph for RLVP. Now, graph for RLVP. We will plot this graph. We have pressure. Pressure means the vapor pressure. Okay. Pressure. And here we have the mole fraction of A. The mole fraction of A. That means at this point, the mole fraction of A will be equal to 0, and the mole fraction of B will be equal to 1. And since B is what? B is a solid. Solid will have no pressure, so it will be here. And if I go to the next end, here it will be what? Chi A is equal to 1 and chi B is equal to 0. That means we have pure A. And in pure A, we have so what will happen? In pure A, we will have a situation where is this is equal to P naught of A. The pressure will be equal to P naught of A. And that is why if I start from chi is equal to 0 and slowly increase the chi A, there will be a point where we will be reaching the P naught of A. We will be reaching the P naught of A, and this is the graph for relative lowering of vapor pressure. Relative lowering of vapor pressure. In the x-axis, we have chi A, and in the y-axis, we have pressure. We have pressure. Now, please remember that this will be chi A. That means the mole fraction of solvent. Chi A. That means the mole fraction of solvent. Please write this down. Let me know when you're done. Done, guys?
Yes, sir.
Okay. Zad, आपके स्कूल में solution हो गया?
Yes.
So what is going on now?
So now हमारा चल रहा है alcohols and phenols.
What? Sorry.
Alcohol, phenol, and ethers.
Haloalkene, halorine हो गया?
Yes.
Okay, so from solution they have now shifted to organic chemistry. Acha. Wait a second. Do you have any exams that is coming?
Yesterday, like हमारा yeah, हमें exam आने वाले हैं after 1 month शायद.
Sorry?
After 1 month maybe.
After 1 month, okay. What about you, Alina?
Sir, we have completed solutions and then अभी हम लोग haloalkanes वाले chapter पे start मतलब किया है, and then we will be having tests on in the month of June.
In the month of June.
Yeah.
Okay. Okay, fine. So solutions से haloalkene आपके भी केस में है ना?
Yes.
Right, Alina?
Yes.
Okay. Do the teachers tell you like rather Do you ask why they are going that way?
सर एक्चुअली वो हमारे यूनिट सारे उसके लिए जो पोर्शंस हमें मिले उसके हिसाब से टीचर्स आर गोइंग. कुछ बच्चों ने पूछा था हमारे क्लास से तो टीचर्स वर लाइक ये जो है हमारे यूनिट्स के लिए दिए हुए हैं. दैट्स व्हाई.
यूनिट्स यानी कि तो यूनिट्स तो वो खुद ही डिसाइड करते होंगे ना, टीचर्स जो आपके स्कूल के हैं, है ना, तो उनको कौन देगा? अच्छा, सो दे आर जस्ट गिविंग यू एन आंसर फॉर द सेक ऑफ गिविंग यू एन आंसर. ठीक है. सो ओके देन आई गेस वी नीड टू हैव सम क्लासेस ऑन हैलो अल्कीन, है ना. कुछ एक्स्ट्रा क्लास लगा देंगे जब आप लोग के एग्जाम्स, जब एग्जाम्स नजदीक होंगे ना, then we can put up. Or if you have any doubts on haloalkenes and haloarenes, then you can just let me know. We can have one extra class someday in the week. Okay.
Okay, sir.
Okay. Same goes for you also, Zad.
Okay.
Otherwise, I will also call you for a few lectures on haloalkene, haloarenes. Okay, organic part. यहाँ पे आप लोग doubts वगैरह discuss कर सकते हैं. Okay. Next is the elevation in boiling point. ठीक है. So relative lowering of vapor pressure is clear, right? Yes or no?
Yes.
Yes, sir.
Okay. Elevation in boiling point. Elevation in boiling point. Acha, we just saw, right? We just saw that the vapor pressure of solution will be lowered. Yes or no? The vapor pressure of solution will be lowered. Correct? Hai?
Yes.
Yes, sir.
Okay. The vapor pressure will be lowered. That means initially, if let us say the solvent, it had a vapor pressure of, let us say, in terms of atmosphere, 0.5 atm. The solution, it will have 0.2 atm. We can say that. Correct? Hai? Now,
Yes.
if I want to boil, both the solvent and solutions vapor pressure should reach how much? 1 atm. Correct? Yes or no?
Yeah.
Now you tell me which will require more, the solvent or the solution? Which will require more temperature or more heat in order to reach 1 atm? 0.5 से 1 atm पहुंचना या फिर 0.2 से? Which will require higher temperature?
I think solvent.
Solution. Yeah.
Solution, na?
Yeah.
Yes, Zad?
Yes, yes.
Why solution?
So because there is solvent and plus there is solute, so there will be more. There will be needed more temperature to rise 180.
Alina, why solution?
Sir, because इसके पास 0.2 atm है and it has to gain
A lot more vapor pressure, right?
Yeah.
Is that you got it?
Yes.
Right, because the vapor pressure is lowered. Are you here, Zad? Why it seems like you are not here? Okay. So for elevation in boiling point, please write. What is boiling point? First of all, a boiling point is a temperature. The temperature at which the vapor pressure is equal to the atmospheric pressure. The atmospheric pressure. Now, since vapor pressure of solution is vapor pressure of a solution, let me write one more part here. Vapor pressure of a solution of non-volatile solute. Non-volatile solute is low, hence the solution will require higher temperature to reach vapor pressure that is equal to the atmospheric pressure. To the atmospheric pressure. Okay. So here you can write a point that adding non-volatile solute, leads to the solute particles occupying some space on the surface of solution, which hinders the what? Which hinders the conversion of liquid to vapor. Okay, please write this point. Then you will look at the graph. Okay, please write. Graph for elevation in boiling point. Now, since we are boiling things, so here again we will be plotting for vapor pressure, and in this case here we will be plotting for temperature in Kelvin scale. Okay, please remember we will be measuring temperature in Kelvin scale. Now, since we are boiling something, so unit or value of pressure which is very important is 1 atm. So we will mark that this is 1 atm here. Mark this is 1 atm. Let us also plot this in here.
So solvent will have less vapor pressure.
Sorry.
So solvent like water will have less vapor pressure.
Less than what?
Less than solute.
No. Why are you asking that?
I remember something.
What do you remember?
In class, someone told. That's why I asked this question.
It depends what is the solute ना. Solute अगर gas होगा तब तो vapor pressure ज़्यादा होगा solute का है ना. But if solute is a solid, then solid solute will have no vapor pressure. नमक से vapors नहीं निकलते ना.
Yes.
Glucose से भी नहीं निकलता, चीनी से भी नहीं निकलता, right?
But maybe it was NaCl. That's it.
NaCl, salt से भी नहीं निकलेगा vapor तो, है ना? So obviously
yes.
the vapor pressure of water will always be greater than that of any solid, है ना?
Yes.
चलिए, now let us come back to the class. Now let us start with the temperature, which is, let us say, normal room temperature ना. So यहाँ पे हमने mark किया इसको, and let us say that the vapor pressure will be somewhere here. It will obviously not be boiling, है ना? If you have any solvent, let us say we have water itself, so water will not boil at 25 degrees Celsius, right? That is why we will say that vapor pressure is lower than 1 atm. Vapor pressure is lower than 1 atm. But obviously, if I start to heat this, then we will be moving in the rightward direction, and also the vapor pressure will increase like this, like this, like this, like this. And at some temperature, it will reach 1 atm. It is reaching 1 atm. So what is the temperature at which it is reaching 1 atm? We'll mark that down. Oops. Okay, so this is the point. Now this is the point where you have the temperature at which the pure solvent is boiling. And obviously, if I mix a solute, which is solid, the vapor pressure will be lowered. The vapor pressure will be here. Now this is the vapor pressure of the solution because we have added a non-volatile solute. And if I increase the temperature, it will also follow the same kind of curve. It will reach here. Now at this point, at this temperature, what will happen? It will start to boil. It will start to boil. And as you can see, right, this temperature here. So one, this is for solvent, pure solvent. And the red one is for solution. Okay. So we'll call this point as, this is for pure solvent. So this will be T naught of B. That means the temperature at which the pure solvent boils, and this is TB. This will be just a TB. That means here the solution is boiling. So tell me which is higher, T naught B or TB? Which is higher?
So TB.
TB is higher, right? TB is higher. Okay, so you can write here 2 points. T naught of B is the boiling point of pure solvent. TB is the boiling point of solution. Okay. So we can write also one more thing now. Delta TB. The difference in the boiling point will be equal to T naught B minus TB. Okay. You'll always write T naught B minus TB because T naught B is what? Wait a second. Write this TB minus T naught B. Positive लेके चलना ना difference. We should keep the difference as positive, so it will be TB minus T naught B because the boiling point of solution is higher than boiling point of the pure solvent. That is why TB minus T naught B. Please write this down. Let me know when you're done. Done, both of you? Acha. Z done?
Yes, sir.
Now tell me, if I increase the amount of solute, then as we are increasing the amount of solute, the temperature required to boil will also increase, yes or no?
Yes.
Yes, sir.
Right? So you can write delta TB. This is the difference of the temperature. Now the temperature, if the TB will start to rise, then the difference will also increase. We can write delta TB. That means the difference in the boiling point of solvent and the solution is directly proportional to the amount of solute that we are adding. It's directly proportional to the concentration of solute. Now the concentration term which matched the values was molality. We wrote delta TB is directly proportional to molality. Okay, directly proportional to molality. And in order to remove that proportionality sign, we'll write a delta TB is equal to what? It is equal to Kb into M. Small m. What is small m? Small m is the molality. So what is the delta TB? Delta TB is TB minus T naught B. What is Kb? Kb is a constant. Kb is a constant. It has many names. One of its name is molal elevation constant. Molal elevation constant. There is another name for it. It is known as boiling point elevation constant. Boiling point elevation constant. Boiling point elevation constant. The next name is ebullioscopic constant. Ebullioscopic constant. What is M here? M here is the molality of solution. Molality of solution. Then yes or no, please tell me.
Yes.
Okay. Achha. Let us see what is Kb. Let us see what is Kb for a while. the molar elevation constant Kb. Acha. If I take for a solution of 1 molar, that means the molality is equal to 1, delta Tb will be equal to how much? Will be equal to Kb only, right? So from here we can define Kb. What is Kb? Kb is the elevation in boiling point of a solution whose concentration is 1 mole per kg. So this is the definition. If they ask you to define what is Kb, then you will define Kb as Kb is the elevation in boiling point of a solution whose concentration is 1 mole per kg. What is the unit for Kb? Unit. So we know that delta Tb is equal to Kb into m, right? So Kb will be equal to how much? Kb will be equal to delta Tb upon m. So delta Tb will be in terms of Kelvin, m will be in terms of moles per kg, right? So now, as you can see, what will be the unit? This kg will go above and it will become kg 1 positive, and a mole will become mole inverse. So it will be unit will be Kelvin kg per mole. Kelvin kg per mole. Okay, this is the unit for Kb. Please write this down. Kelvin kg per mole. Kelvin kg per mole. Both of you done?
Yes.
Yes, sir.
All right. Determination of molar mass of solute using elevation in boiling point. Using what? Using the elevation in boiling point. Now listen here. So we know delta Tb. Delta Tb is equal to Kb into m. Now we can write this as Kb into what is molality? Molality is nothing but number of moles of solute divided by mass of solvent in kg. Mass of solvent in kg. Okay, this will be Kb into number of moles of B will be equal to what? Nb is equal to what? The given mass upon the molar mass. We can write this as the given mass upon the molar mass, that means Nb into Wa, right, in kg. Is that right, Jasola? Please tell me.
Yes.
Sir.
Okay, now this we have delta Tb here. Now we can easily write that Nb is equal to the molar mass of the solute is equal to what? It is equal to Kb into Wb upon. We will have delta Tb into W of A in kg. Is that right, yes or no? Please tell me.
Yes.
Okay, this is W of A in kg. Okay, this is W of A in kg. Now you can also see if I want to convert this, see, if I want to Kb into Wb into 1000 divided by delta Tb into W of A. Okay. So if you write this down, then it is done. Done. Okay. Write a question. 18 gram of glucose. 18 gram of glucose was dissolved in 1 kg of water. 1 kg of what? 1 kg of water. How to calculate? Calculate the temperature at which this solution will boil. Okay. Kb for water. Kb for water is what? 0.52 Kelvin kg per mole. Kelvin kg per mole. Okay. So I will tell you how to do this, and then you will do it. Okay. So we know that delta TB is equal to Kb into M. So delta TB is what? Delta TB is PV minus T naught B, which is equal to Kb into M. The molar mass, that means molality is what? NB upon W of A in kg. So this W of A is already given, right? Kb is already given. You need to calculate NB. NB आप calculate लीजिएगा. NB is equal to the given mass upon the molar mass of solute. The given mass is given. The molar mass of solute, I hope you know it. Now, then you will just plug in the value like this. This TB will be equal to how much? T naught B plus Kb into whatever the number of moles is there, divided by 1 kg, right? Divided by 1 kg. So you can also write what is Kb. Kb is 0.52. है ना? So can somebody tell me what is this value? T naught B कितना होगा? Alina and Zain. What will be the value for T naught B?
1 kg.
T naught B. What is T naught B?
Sorry.
What is T naught B? What is T naught B?
Sir, is it glucose?
Sorry?
सर सॉल्वेंट का जो प्रेशर है मतलब वेपर प्रेशर है वो T0
अरे आप लोग लिख ही नहीं रहे हैं क्या अपने नोटबुक में? नोटबुक अभी लिखाया है हमने. आप लोग कहाँ है ध्यान आप लोगों का? पता नहीं. What is T naught B?
the vapor pressure of solvent.
या अल्लाह, कहाँ है आप लोग? आके आप लोगों ने क्या बेच दिए हैं क्या? कहाँ पढ़ रहे हैं? क्या पढ़ रहे हैं आप लोग?
Sorry, boiling point.
Sorry, boiling point. Alina, what is T naught B?
Sir, it's boiling point of pure solvent.
What will be the value for T naught B here? Tell me.
Sir, will it be glucose dissolved in 1 kg?
अरे what is T naught B again, Alina?
It's the boiling point of pure solvent.
Boiling point, na? What it is? Boiling point of
Pure solvent.
what is the solvent?
Glucose.
Very good. Solute और solvent नहीं पता है, solution खत्म होने वाला है. ऐसे कैसे चलेगा काम, अलीना?
Sorry, it was water के लिए, so it will be 1 kg.
Boiling point, Alina. Boiling point 1 kg. Alina, what are you saying? Can you hear yourself? Yes, Alina.
Yes, sir.
What is T naught B? Once again, what is T naught B?
Boiling point
Of
pure solvent.
what is the solvent in this case? Sorry.
Sir,
What
is
is
it
the?
water?
अच्छा, आपको confusion है?
Yes, sir.
Acha. So you know that there will be two components. One will be solvent, the other will be solute, right?
Yes, sir.
Okay. Solute is the component which is present in minor amount. Solvent is the component which is present in major amount. Clear hai?
Yes, sir.
Now you tell me which is present in minor amount, glucose या water? कौन सा कम amount में present है?
Sir, water is present in less amount.
Water is present in
Less amount.
Can you read the first line, please?
Sorry, water is
अरे
present in
सॉरी
all.
का हम क्या करें अलीना? अलीना सॉरी का हम क्या करें? अभी जो आपने कहा है मेरा दिमाग फट गया. What should I do with that? Sorry. Water is present in less amount. कहाँ दिमाग है अलीना आपका? Are you here? You यही है ना? क्लास में है ना?
Yes, sir.
Why you are saying like इतना ज्यादा गलती कैसे हो सकता है किसी से? Drink some water, है ना? Please try to be more attentive. Okay. Now, अब बताइए आप. What is the solvent here, Alina? Yes, Alina. What is the solvent?
18 grams of glucose.
Which ये अलीना ऐसे कैसे काम चलेगा? लिखिए आप. Tell me. Solvent is present in major amount या minor amount? It is larger or it is in less amount? Solvent.
Less amount. No, sorry, it is the largest amount and the solute is the less.
Larger amount. And solute? Lesser amount. अब बताइए इस क्वेश्चन में सॉल्वेंट क्या है? Which is present in larger amount? Which is present in larger amount?
1 kg of 1 kg of water is present.
1 kg छोड़िए ना, 1 kg छोड़िए. What is present? Solvent और solute में बताइए क्या होगा solvent? Amount आप छोड़िए, बताइए what is the solvent? Water या glucose?
Water.
Yeah. And solute is
Glucose.
glucose. अब बताइए T naught B क्या होता है? What is T naught B?
It is
T naught B is the
pure boiling point of pure solvent. So it will be water का pure solvent.
water का pure solvent.
जो
अरे water
boiling
तो boiling.
point, sorry, boiling
हाँ
point.
water. पानी पीजिए आप, water पीजिए, water. हाँ बताइए boiling point of water will be then 373.15 Kelvin. Okay. ठीक है, Kelvin में लेना सबको. Okay, because the kb is also in Kelvin. चलिए please write this down. Calculate NB. आप पूछ सकते हैं ना अलीना, if you even if you don't know simple things ना solute के बारे में तो आप पूछ लेते हैं. हाँ बताइए.
Sir, the same question came in my exam and the answer was 373.202.
373.202. 373.2 के करीब ही आएगा. What is the value of NB here? Calculate and tell me in the chat.
So NB is 1/10.
Yes, correct. Lena, see 18 gram here is for glucose and 180 grams per mole is the molecular mass for glucose. ठीक है, इसको याद कर लीजिए. ठीक है, 180 gram. This will be giving you 1/10. यहाँ पे 1/10 रख दीजिए आप. This will be equal to 373.15 into sorry, not into, plus 0.52 into 1/10. So you can write this as 373.15 plus 0.052. This will give you 373 plus 373 plus क्या लिख रहे हैं? 373 point लिख देते हैं. 15 and here you have 052, so 25510 and 202 Kelvin. Done?
Yes.
Yes, sir.
Write another question. Solution of glycerol that is C3H8O3. A solution of glycerol in water was prepared by dissolving some glycerol in 500 grams of water. In 500 gram of water. The solution has boiling point of 100.42 degrees Celsius. 100.42 degrees Celsius. Question is what amount of glycerol was added? What amount of glycerol was added to make the solution? Okay, again, Kb for water is equal to 0.52 Kelvin kg per mole. Okay, so in this question, you have been asked what is the amount of glycerol that has been added. So this is also a simple question. You all know the T naught B, the delta TB will be equal to Kb into M. You all know M is equal to the number of moles divided by the mass of solvent in kg. And here we know that Nb is equal to Wb upon the molar mass of B. This will be equal to Wb upon the molar mass of B into W of A in kg, right? W of A in kg. Now, if you calculate this part here, you can write this as Kb into Wb upon Mb into Wa in kg. Okay, so delta Tb will be equal to how much? अच्छा, एक चीज आप लोग को हम बता रहे हैं, please keep this in mind. Okay, please keep this in mind. Difference in temperature is equal even if you take degree Celsius or you take the Kelvin scale. Difference, ठीक है? Please remember the difference is always equal. ठीक है? The difference is always equal. You can see here 100.42, right? 100.42 means in Kelvin scale it will be equal to how much? 373, right? 373.57. 373.57 minus 100 degrees Celsius is 373.15. The delta TB निकाल रहे हैं यहाँ पे. So if you calculate this also, this will be equal to how much? This will be equal to 7 minus 5. 7 minus 5 will give you 2. 5 minus 1 will give you 4. 0.42 degrees Celsius. And if you see this 100.42 minus 100, this is also going to give you 0.42. Okay. So no matter whether it is degree Celsius or Kelvin, the difference will always be the same. So the delta TB will be equal to 0.42. Okay, 0.42. And then you can write WB is equal to 0.42 into MB into WA divided by KB. Right, equal to 0.52. So you can write this down. 0.42 into the molar mass of B. Molar mass of glycerol will be equal to how much? C3H8O3, na? C3, that means भारतीय 36 मेडिकल का 8 So, 92 grams per mole. 0.42 into 92 into the mass of solvent in kg. That will be equal to 0.5 kg divided by 0.52. Please calculate this down.
So it's coming 37.2.
Around 37.15, I guess.
Okay.
Yes, sir. I got 37.16.
15. No, 1516 grams. Okay. So this is how you calculate the given mass. Okay. So all of these questions will be formula based. And one more announcement for you guys is that tomorrow I will take a test. Tomorrow there will be a test in my class. Okay. At this time, 4 p.m. Okay. So 4 p.m. say 5:30 p.m. ka schedule hai na. In that we will have a test of half an hour. Okay. In that I will be asking you 3 numericals. Okay. I will be asking you 3 numericals and you have to do all of them right. Okay. You have to do all of them right. 3 numericals. Syllabus will be Henry's law and Rawls law. Okay. Henry's law and Rawls law syllabus hoga aapka. I will be asking you one more thing. There will be one more question from colligative property. ठीक है, जो 2 colligative property हम लोगों ने पढ़ा है, from colligative property there will be one question, है ना, either from the relative lowering of vapor pressure or from the elevation in boiling point, है ना, or from the elevation in boiling point. Is that clear? Yes or no? Please tell me.
Yes, sir.
Yes.
Okay. And also I hope you know that you have an MCQ test also, है ना, जो कि आप शायद Sunday और Monday के बीच में दे सकते हैं. That is there in your web portal or your app, right? Alina and Zad, you know this?
Yes.
Yes.
Every Sunday we have that na. In addition to that you will have a test. अच्छा, ये जो Sunday to Monday वाला है, in that your syllabus is ideal, non-ideal till Azeotropes. Okay, and I think Alina, you have to watch that video of last Sunday. ठीक है? Also make sure है ना, make sure. अच्छा, आप कौन सी classes कर रहे हैं यहाँ पे Alina? Apart from chemistry.
Physics मैं कर रही हूँ लेकिन I'm not joining it.
अच्छा, so देखिए जो भी class आप join कर रहे हैं ना, it will be either Monday, Wednesday, Tuesday, Thursday या Saturday, Sunday. ठीक है?
Okay.
है ना, तो Saturday, Sunday केमिस्ट्री है आपका. अगर आपको लिंक नहीं भी मिले ना तो 999 वाला आप ज्वाइन कर लीजिए. ठीक है?
Okay.
एवरी वीक विदाउट इन, अगर कुछ मतलब मान लीजिए हम छुट्टी पे हम कहीं जा रहे हैं तो आपको पता चल जाएगा वो बात. लेकिन अगर नहीं तो आप ज्वाइन कर लीजिए कीजिए कोई भी लिंक 4 बजे. ठीक है? फिर बोलिए केमिस्ट्री पढ़ना है हमको, फिर वो केमिस्ट्री का लिंक आपको भेज देंगे. ठीक है अलीना?
Yes, sir.
चलो, थैंक यू वेरी मच गाइस. ऑल्सो हेलो अल्केन. हाँ बताइए बताइए.
So can I ask one thing about that alcohol chapter?
हाँ श्योर, टेल मी.
So बेंजीन रिंग के ऊपर एक OH and para पे एक OH. So what will be called? एक at the first position and at the para position.
Yeah.
One name is hydroquinone and other name something it is written like creone or something. Can you write it?
ये अच्छा, ये देखिए ऐसा होता है, क्या बोलते हैं, इट हैज अ टॉटोमर विच इज, एक आपको तो क्यूनोन दिया होगा है ना?
Yes.
क्यूनोन, राइट? अच्छा, देयर विल बी, देयर इज अनदर नेम यू आर सेइंग.
Yeah.
व्हाट इज दैट अनदर नेम?
So it's written like CAUIONON. Cayuinol something.
सी से?
C से.
नहीं देखिए, एक तो अच्छा, आई डोंट नो व्हाट यू आर स्पीकिंग, बट लेट मी टेल यू, दिस इज अ, इसके एक टॉटोमर होता है. तो टॉटोमर इज, you have double bonds here, oxygen here, and then there is oxygen here. Okay, so both of these are tautomers for each other. Okay, both of these are tautomers of each other. So one is named as benzoquinone, or it is known as quinone only, but I can't recall what you are trying to say. This one is quinone.
Yeah, quinone. Yeah. And quinol, hydroquinone.
Hydro. देखिए ये तो बस ये है ना, देखिए दिस इज फॉर क्यूनोन. ओके, एंड इसका जब हाइड्रोक्सी वाला जो पार्ट होता है, दैट इज हाइड्रोक्विनोन. आप सी से बोल रहे थे, वही दिस इज हाइड्रोक्विनोन. ओके, सो क्यूनोन एंड हाइड्रोक्विनोन्स, दीज आर बोथ टॉटोमर्स ऑफ ईच अदर. इसमें क्या पूछना है आपको?
सर एक नाम था, याद नहीं आ रहा. वो सी से शुरू होता है, लाइक यू टोल्ड, नो नेम स्टार्ट्स विद सी.
इन दोनों का तो नहीं होता, नो नेम नहीं, इन दोनों का नहीं होता है.
ओके, लेट मी, थैंक यू.
सी से स्टार्ट होता है, कौन सा नाम? व्हाट डू यू वांट टू आस्क अबाउट दैट? ये बस यही पूछना है कि वो सी से स्टार्ट होता है कोई नाम?
या इट वाज लाइक कैटेकॉल, यहाँ पे रिटन है कैटेकॉल.
अच्छा, कैटेकॉल. ओके, तो उसका तो ये आपका कौन सा है? ये आपका पैरा आइसोमर है, वो आपका आइसो आइसोमर होता है, सॉरी ऑर्थो आइसोमर होता है ना? दैट इज कैटेकॉल. हाँ, इसमें क्या फिर उसकी तरह एक क्या होता है, रिसोर्सिनॉल होता है.
यस,
है ना? रिसोर्सिनॉल इज OH here and there is a para OH. इसमें हाँ, ये वैसे ये सवाल नहीं पूछेंगे, आई होप, जहां तक हमको लगता है. ठीक है, these type of questions are not asked generally in